In example 2, we're going to do the same thing. We're going to add the fact that we're going to graph this in the end. So now this question is asking for the equation of symmetry. Again, it's in general form. Anything that's in general form is difficult to tell characteristics. If we can change it to standard form, it's going to be better. However, this one has an issue already, because I'm going to take out the negative 2. Can you tell that that's going to be your a value? But when I factor the negative 2 out of the negative 2x squared, that's easy. What goes here? It's going to be negative, because it has to be a positive, and it's going to be 5 over 2. And we still have the minus 3 out here. There's a space, there's a space. Whew. The next question is, what would go in here to get a negative 5 over 2? How did we do it when the numbers were nicer? What did we do last time? Numbers were nicer. It was minus 4. It was minus 2. How did you do that? You half it, right? So how do we half 5 halves? 5 over 4. Right? You can just multiply it by a half. And if that's 5 over 4, what goes in the space? You see why this one might be better to do this way instead of trying to do it mental math? Okay? 25 over 16. Yow. Yow. What have we actually done, though? What have we actually done? We actually subtracted 50 over 16, right? If you multiply by 2, you just multiply the top by 2. And 50 over 16, you could reduce that to 25 over 8 if you'd like. Okay? So we've actually subtracted 25 over 8. What needs to go here? We have to do the opposite, so we would have to add this time. We would have to add 25 over 8. How do you add negative 3 plus 25 over 8? You have to get fractions with a common denominator. Are you okay with that negative 3 is negative 24 over 8? So this becomes plus 1 over 8. So if we were about to graph this, well, we are going to graph it, so not if. When we go to graph this, we know that our vertex is at 5 over 4, comma 1/8. How would I graph that? Well, 5 over 4 is 1.25. 1/8 would be about there. There we have 5 over 4, comma 1/8. And what's our rule in this one? We would need to go over 1, down 2. So if I went over 1, that would get me to about here, and then down 2 would be about there. I'm just estimating. If we wanted to find the coordinates of that point, we could. Same thing here. You could go over 1, down 2. So sometimes using the over 1, down 2, especially when you're dealing with fractions, might not be the nicest thing. Your points might not be very nice at all. In that case, you might want to go back to our first graphing strategy. Our first graphing strategy was just plugging in some points. For example, if you plug in 0 for x, what are you going to get? Into the original equation here. If I put a 0 in for x, I'm going to get minus 3. So my graph is a little bit off here. I'll add another tick. 0 minus 3. I know it has that point. For most graphs, they're going to ask you to label the most important point, which is the vertex, and then you will need one extra point to show that you've got the width right. So in this case, having 0, negative 3 would be a great point to label because it was easy to figure out. I just plugged in 0 for x. This question was asking about the axis of symmetry. Remember, the axis of symmetry is what goes through your vertex and cuts the parabola in half. The equation of the axis of symmetry is always x equals, and it's always x equals whatever the x coordinate of your vertex is. So it'll be x equals 5 over 4. What made this one more difficult? The fractions. Okay? Is it any different than the last one? Not really. We had a negative, so it went down instead of up. And you had to be a little bit careful when you factored the negative out. But other than that, it is pretty much the same. So questions for this one are 8 and 10.